Hello students, welcome to the next lecture on the Laplace transformation. Today we will see what is the first shifting theorem. Myself, Dr. Garg. So which is working in the School of Mathematics, Thapar Institute, India. So what is the first shifting theorem of the Laplace transformation is if the Laplace transformation of the f exists, that is this condition holds, then you can find the Laplace transformation of exponential part is nothing but replacing s to the s minus a. What is the physical significance of this? How we can solve that? We will see here. So firstly we will see how you can prove that. Now since it is given that this is the Laplace transformation, so by the definition of the Laplace it can be written as 0 to infinity of this provided here. Now what you want to find the Laplace of this. We can start from here. By the definition this is e raised to power minus s into f of t, but here is this. Now you can combine the pair of this and this. What will happen here? Now again you can compare with here what is happening here. This is s is nothing but my s minus a. That is the required proof of this first shifting theorem. Now what is the significance of this? How you can solve them? We will see the 10 examples in this video so that you can easily get the concept behind that. So firstly I will tell you the tips or the rule what you have. If you have to find the Laplace transformation of the anything in which e raised to power something is present, what you can do is whenever e raised to power something is present, then always use the first shifting theorem. How you can use them? You can firstly find the Laplace transformation of this part, and whatever the answer you have to obtain, simply replace s with the s minus a. How we can do that? We will see in this firstly 6 examples and then later on 4 others. You can see exponential part present, exponential part present, exponential part present. Here is also present, but they are not present. But we can still solve this with the help of here. How we can solve? We will see in this way. Now before solving these examples are there, you have to remember all these Laplace formulas. Laplace of the constants, exponential, trigonometric, polynomials, sine, cosine and so on. Based on this formula we will start with here. So let's start with the first question. So what you can do is, since exponential part is present, so you firstly skip this part and try to find the Laplace of this sine of 2t. So how you can do that? You can simply remember this formula. This is a is nothing but my 2 in this example. So it will be my 2 upon s square plus of 2 square. That is here 2 upon s square plus 4. Now since exponential part is present, what you can do is you can simply replace s to be s minus a. What is the a in this case is minus of 3, it's a plus 3. So it means wherever the s written, you can simply replace s to be the s plus 3 is the required answer. Similarly, you can see on this part, what you can do is you have to start with the Laplace transformation of here. Whatever the answer you can obtain, simply replace s to be s minus a is my 1. So all of you know that what is the Laplace transformation of here. This is nothing but n plus 1, this is gamma function of the n plus 1 upon s raised to power n plus 1 here. Now what is the gamma function of the n is nothing but my n minus 1 factorial if n is my positive integer. So what is that 2 factorial? 2 factorial is nothing but my here. Now you get the Laplace transformation of here. Now what you can do is simply replace s to be s minus 1 is the required. Sorry, it's a, if it is a minus here, then it is a minus, then it's s to be s plus 1. How you can do this one? So since again the exponential part is present, so how you can solve them? So we have to firstly find the Laplace transformation of here. How you can solve them? You can simply use a minus b whole square. It can be written like this way. You can solve them here. Again, Laplace transformation of this is nothing but my n plus 1 upon s raised to power n plus 1. Laplace transformation of the constant is nothing but my k by s. So you can substitute here. This is my gamma function of 3 upon s cube. This is 4 by s and this is power 1. So gamma function of the 2 upon s square. How you can find the gamma function of 3? Since it is an integer, so it is a 2 factorial. Gamma function of the 2 is nothing but my 1 factorial. So that 2 factorial is nothing but 2 gamma function of here. Now this is the Laplace transformation of here. Now what you can do is you can simply replace s to be s minus a. That is, you can replace s to be s plus 1 by using shifting first theorem. Wherever the s present, you can simply replace them to be here. How you can solve this problem? Since there is no exponential part present, so there are the two ways are there. The first method we will discuss in this video, that is with the help of shifting first theorem. While in the second method, since it's a polynomial term present here, the second method we will discuss after this video. So how you can solve this, the shifting first theorem? It means your target is to express this in terms of the exponential. So can you write this cosine cos terms into the exponential part? Yes, you can easily do that with the help of this function. Now you can multiply this with respect to the t on both sides, you will get here. Now you can write here. Now you can see this the exponential part present. What you can do is you have to find the Laplace of this. What is that? This is power is 1. So this is s upon here. What is the gamma function of the 2 is 1 factorial upon s square, that is 1 by s square. And for here, this is again, so what will happen? This part is my 1 by s square. This is also be the 1 by s square. Now for this exponential part, we have to replace s to be s minus a. And for this part, we have to replace by here. So that is, this is the integration, this is the Laplace transformation of here. We can substitute this value in this, we will get s minus a, s minus a. Now since this is the real components are there, so what you can do is half will be common. You can take the LCM and you can simplify it. You can solve the a plus b whole square. You will get this as the right answer. Similarly, you can see how you can solve this part. Again, this is the polynomial, so there are the two ways. First method we can do by shifting the first theorem, and since this is the polynomial, we will see the second method after this video. So again, you can express this cosine terms in terms of here. Now you can multiply them, you can write like this way. What is the answer of this is, now since it is exponential part, so we will try to find the Laplace of t square. What is that? This is nothing but gamma function of 3 upon s cube. Gamma function of 3 is s2s. So here, so what is the answer of this is gamma function of 2. You can replace this s with the help of s minus of a. This part half will be common. Again, this will be my s cube. So what is the s in this case is s minus a. So minus minus plus of a. So that is the required here. Now you can simplify it. You can take half, it cancel out. You can take the LCM, and after the calculation you will get this right answer. How you can solve this problem is, since again this is the exponential part present, so you have to find the Laplace transformation of here. What is the Laplace transformation of this? Is nothing but my here. Now what is that? You can simply replace s to be s minus here in this case. Now here is this. So by shifting first theorem, you can simply replace s to be the s minus a. Now look at the three more examples are there. So how you can solve these problems are there. Look at that. None of the problem is in the exponential part. So again, what you can do is you can simply replace this sign part as of this of minus t by 2. Otherwise, you can simply replace this as iota t minus of, this is a cos you can use. So you can use either of them. There is no need to use both of them. It will take a lengthy calculation. So you can simply use one of them. So I just consider the first part of this. I can write exponential hyperbolic part this. I can open this bracket. Now you can take the Laplace transformation on the both sides. You will get here. What is the Laplace of, you can see what is the Laplace of the cos of t. This is nothing but s upon s square plus a square. Now for this part, what you can do is you can simply replace s to be the s minus a. So I can replace s to be the s minus 1. And for here again this is this. So s to be s minus a, minus minus plus. So you can see I have replaced here is the required answer. Now simplify again, this is the exponential part already present. So you have to start with the Laplace of the sine hyperbolic. So as the standard formula it is mentioned here, this is nothing but s square a upon here. Now you can start from here. This is nothing but a upon this exponential part present. So you can simply replace s to be s plus 2. You will get the required answer. Look at the last part are here. So what you can do is, in this case exponential part present, but here the term is in the product sign. So what you can do is you can simplify this. How you can simplify? You can simply use this formula. 2 sin a cos b is nothing but sin a plus b sin a minus b. I can write like here. Now what is the target of this? This is the exponential part present. So our target is to find the Laplace of this portion. So how you can find that? What is the Laplace of the sine is a upon s square plus a square. So this is 3 upon s square plus 9. This is 1, so 1 upon here. Now for this part, what you can do, you have to simply replace s to be the s minus a, that is a 4. Half will be multiplied, that is the, simply replace s to be the s minus 4 is the required answer. So this is the way you can solve this shifting first theorem problems here. We will see in the next class how you can multiply, like here all these 4 questions we have solved in this lecture also, but here you can see the multiplication of t, that is a polynomial of this. You can see all are the multiplied by the t. How you can solve this? First method we already solved with the help of shifting first theorem. Next part we will see how you can solve the same problem with the help of multiplication rule. Till then you can simply follow this link and subscribe the channel for finding the more videos. Best of luck students. Happy learning.